Now that we've learned a little bit about weathering, which again is the breakdown of rocks, we're going to look at how soil is made, because weathering is directly linked to the process of soil being made. So what is soil? I always like to first ask students, what do you think the difference in soil and dirt is? And typically I get all sorts of answers like the composition of it is different, but think about that for a second. What do you think is different, the difference between soil and dirt? Well, when I was in geology at ECU, what I learned is that dirt is simply misplaced soil. So if soil is in the ground where plants are growing and all of that stuff, it is called soil. But the moment it gets on your shoe, they call it dirt. Now, I don't know how universal that is, but I've always kind of enjoyed that definition, so I like to share it with y'all. So soil is simply the upper layer of the earth where plants grow. So we've talked about the crust in Unit 4, and we talked about how the crust can be miles deep and that it's very rocky. Well, the very, very top of the crust is where we will find our soil. And has a lot of, we'll look at the weathered material that's within it, and that's what gives it the nutrients for your plants to grow. Now, soil is formed through weathering. So the crust is made up of rocks, and when the very top surface of those rocks get weathered over many years, that rock gets weathered into very fine sediments, and that is one of the things that makes up soil. The other thing that makes up soil is organic matter. Now, you need to know this. This is very important. There are two things that make up the composition of soil, and that is the weathered material and the broken down organic matter, or that decayed organic matter. When we're looking at organic matter, we're actually looking at things that have died. For instance, when the fall comes around and the leaves on the trees all come down to the ground, they fall to the ground, hence the name fall. Once they break down, or say you got a little squirrel on the side of the road who just didn't quite make it across the street before that car came. When that squirrel or those leaves start to decompose, we call that the breakdown of organic matter. And that's what gives the soil some of its nutrients. So again, repeating this because it's so important. Soil is made up of two things: weathered material and broken down organic matter, aka decayed material. Let's keep going. There are a few factors that affect soil formation. So the first thing is going to be the parent material, which is the mineral source. So what affects the formation of you are your parents, okay? The DNA from your parents that went together and created you, that affects your formation. Well, the parent of soil is going to affect what it looks like. And the parent of all soil is rocks. Because soil is made up of weathered material, and weathering is the breakdown of rocks. So once rocks are broken down, lots and lots, you can eventually get soil, obviously once it's mixed with that weathered material. And remember, what are rocks made up of? Well, rocks are made up of minerals. So a lot of that broken down parent material is what we would call a mineral source, because the rocks are made up of minerals. The other thing that affects the formation of your soil is time. Thicker soils take more time to form. Now, we don't really think too much of dirt, but dirt is a resource that takes a really long time to form. I want you to look at a rock and think of how long it would take to turn into topsoil when it's just sitting there. So our soil takes such a long time, so the longer it has, the more time it has to form. So more time equals thicker soil. Next, we have climate. Now, what type of climate do you think is going to cause the fastest weathering? And remember, climate's going to be the temperature and moisture. Well, whatever climate causes faster weathering will also cause more soil formation, because the first process in making dirt is weathering. So the climate that's going to lead to the thickest soils is going to be your warm, moist climates, because that is the climate where weathering occurs the fastest. Therefore, that's the climate where you're going to have the most soil. And then you have organisms. The organisms that live in the dirt are going to be able to affect the dirt. Think about a nice little worm that lives in there, a little earthworm. I used to help my grandma plant pansies when I was little. And if we ever saw a worm, she would tell me, keep that worm and put that worm in the hole before I put my plant down. Because she knew that worms are good for the dirt. That worm, as he's digging through that dirt, he's going to eat some of it and he's going to poop that dirt right back out. And that's going to give the soil extra nutrients, which is going to be good for your plants. So those burrowing animals are actually very good. And then you have slope. Now this is really self-explanatory, but think about it. You got a hill, like the little mountain I just drew. At the top of the hill or the mountain, you're going to have very thin dirt. And at the bottom, it's going to be much more thick. And why is that thinner at the top and then at the bottom? Because when it rains or when the wind blows, all the dirt's simply going to travel down the hill. So the top of the hill has thicker soil and the top of the hill has thinner soil and the bottom of the hill is going to have the thicker soil. So those are the things that affect your soil formation. A soil profile. If you're ever talking about your profile, you're kind of talking about the side of you. I don't know if y'all ever made these when you were younger, but our teachers we'd stand in front of like the projector and then shine a light, and our profile would be reflected on the wall, and then they would trace it, and you just have like an outline of your body. Well, I don't know if y'all ever did that, but a soil profile is simply like the outline of what the dirt would look like. And there's three main layers we look at when we're looking at a soil profile. Now, we call these horizons, but these soil horizons, they simply are layers. Horizon's just another word for it. So we're going to talk about these three main horizons, A, B, and C, but then on the next two slides, we're going to look at some other horizons that are sometimes found there within there as well. So your first horizon is going to be the A horizon. The A horizon is the upper layer, and it's also called your topsoil. And so this makes sense. If it's the upper layer, then it is on top, so that is the topsoil. It's very soft, loose dirt. You can buy tons of bags of topsoil at Lowe's or something. Your B horizon is the next one. This is the middle layer. It's the subsoil because it's under the topsoil. Remember when we looked in Unit 4 at the your subduction zone, or like a submarine, meaning it is under. So the subsoil is under the topsoil, and it's really made up of a lot of clay. Then you have your C horizon. The C horizon is the bottom layer, and it's very rocky. And the reason it's so rocky and has these large chunks of rocks within it is because it is not by the surface, so it's not going to be able to be weathered as much because it's protected by your other horizons. So those are the three main ones. Now, people always ask me, how thick is each horizon? There's not a certain thickness designated to each one because no matter where you are, they're going to each look a little bit different depending on the environment. Again, if you're at the top of a hill, then your horizons are going to look very different than if you're at the bottom of the hill. So there's no set answer for that. But let's go ahead and look a little bit more at those horizons. So there's two other layers that we can talk about. And that's going to be the O horizon and the parent material. The O horizon stands for your organic matter. This is that decayed plant and animal tissue. This is what I was talking about when I gave that beautiful reference of your leaves that fell from a tree and your poor little squirrel who didn't quite make it across the road, okay? That decayed plant and animal tissue is going to break down and create that organic matter. And so the reason it's called the O horizon is because it stands for organic, okay? You're going to find the O horizon on top. So you typically have ABC, and on the very, very top, you're going to have that O horizon. And the reason the O horizon is on top is because think about it. If you have a plant and that plant dies, it dies right there on the surface of the ground. And so that would make sense that the surface of the ground is where you're going to find most of this decayed matter. The parent material is going to be the rocks that first gave, I guess you'd say, birth or weathered down to become the soil. And so these are going to be large rocks that we often call bedrock, and they're going to be at the very, very bottom of the soil profile. And I have a picture that we can take a look at. So here's two pictures because they're both a little bit different, but they're good examples. So let's look at the one here on the left. You have your C horizon, and you can see there's some large chunks of rocks drawn within there. You have the B horizon, your A horizon here, and then look, your O horizon's on the very top surface, and notice the O horizon is basically shown as this like darker line on top. And that's typically what they'll show, is just a thick bolded line on the very, very top. So you have the O horizon, then A, B, C. And notice this profile doesn't actually have the parent material shown. This one over here, it has that parent material, it has the bedrock. Then you get to your horizon C, your horizon B, and then over here we have your A. Now this one isn't showing your O horizon, but if it was going to show your O horizon, then this is typically what they would do. They would just draw that darker bold line, and that would be that O horizon. It describes the O horizon right here, but it didn't actually give it a spot to label it. But that's an example of what your soil profile would actually look like. Now, characteristics of the soil. So basically, what is soil made up of? Well, 45% of soil is simply mineral matter. And that would make sense that half of your soil is mineral matter because, again, what did soil start out as? It started out as a rock, and rocks are made up of minerals. So that makes sense. 25% of your soil is air. Air is actually very important to your dirt. I don't know if you've ever heard of this, but they say it's good to aerate your lawn. So sometimes people will get these little machines or these little tools that just go through and poke holes in the ground. Or if you're ever going to plant like a vegetable garden, you may till up the ground some. What you're doing is you're mixing in the air within that dirt. And so that's actually very good for it. And then you have 5% humus. Not humus, humus. Okay? Humus is your decayed remains of organisms. So humus would be found in which horizon? Think about that. Which horizon that we just talked about is where you would find humus? Well, if humus is decayed remains of organisms, it would be found in that O horizon. Now, I don't know if any of you have ever heard of hummus, okay? Hummus is a snack. I really like the spicy hummus that Aldi has. And hummus is simply crushed up chickpeas, and it just is like a little bean dip. Don't get that confused with humus. Humus is very different. I had one student who came up with the example that hummus is crushed up chickpeas and humus is crushed up chicks because it's that decayed organic matter. A little bit dark, but when she told that to the whole class, it seemed to stick with them. So if that helps you remember that, humus is crushed up chickpeas. Hummus is crushed up chickpeas. Humus is crushed up chicks. I would definitely not want to eat humus, only the hummus. Okay, so that is your your soil composition, mainly made up of minerals. So your characteristics of soil texture. Now, a big thing to know, everybody listen, soil texture equals size. When we are looking at the texture of soil, we are simply looking at particle size, okay? So soil texture is referring to the size part of particles, okay? The particle size. Now, to help you think about this, typically when we talk about texture, we're saying how something feels. If I ask what is soil texture and you tell me it's how rocks feel or how dirt feels, I'm going to say no, you're wrong. It's the particle size. Now, one of the reasons they call it texture, though, is because think about if you are holding a handful of gravel and then you're holding a handful of sand, they are going to feel different in your hands. And the reason they feel different is because the gravel is a much larger size than the soil is, or the sand is. So that's why they call it texture, but it's all based on size, okay? Sand is one texture. So there's 3 textures we're going to look at. Sand is the first texture. Sand is the largest of the soil texture. So if I'm going to draw an example of sand, there's your sand particle, okay? Silt is the second part or texture size we're going to look at. If I'm going to draw a picture of silt in comparison to sand, then there we go. So I have sand, which is much larger than silt, and then I'm going to have my last particle size, which is clay, which would be that teeny, teeny, tiny dot I just added up there. Clay is by far the absolute smallest particle size, okay? Now, you all know what sand looks like. You can pick up sand and you can see each individual particle within it. So that's what we are talking about when we say the large particle size. Now, if you ever get cooking flour and you put that in your hand and you look at it, how small each particle of flour is, that's about the size of a silt particle. And then when you look at clay, now if you get like Play-Doh or actual red clay from outside and you rub it around in your hands, you can't, it's just a sticky mess. You can't even see the little particle sizes because they are so small. So sand is the largest particle size, number 1. Silt is the second largest, number 2. And then number 3 is clay. That's the smallest. Now loam, on the other hand, loam is not a texture. It is actually a mixture of all 3 textures. So if I gave you a bowl and I put 1 cup sand, 1 cup silt, and 1 cup clay and mixed it all up, that would give me what we call loam. Plants love loam. And maybe you should write that down, or maybe you should say it out loud, okay? Plants love loam. Loam is the best soil for plants because it has a little bit of everything for what they need. Just kind of like Goldilocks, it's just right. It's got that large particle size of sand to have good drainage. It has the good nutrients from that silt, and then it has clay, which is actually going to help retain some of that water because it's so teeny, teeny, tiny. So your 3 texture sizes, largest is sand, second largest is silt, smallest is clay. Mix all 3 of them up evenly, and you get loam. That's very important to know. Let's move on. An important thing to be able to read is what we call the soil texture triangle. And when we are done with these notes here in a second, you're actually going to do a worksheet with the soil texture triangle. It's very common to see one of these soil triangles on a test. So this is a big deal to know. It's very, very simple to read, but you need to pay attention, okay? Notice over here you have clay. Down here you have sand, and over here you have silt. In our chart, we have 3 percentages. We have clay, silt, and sand. And now what does a percentage always equal? A percentage always adds up to 100. So what we're going to do is find where all 3 of these intersect, and that's going to give us our texture type. So first, let's look at clay. The clay for this first sample is 60. Now, let me clear my screen because I actually drew over the number 60. So looking at this, for our first sample, we have 60. Well, if I come over to the clay side, and I find 60, I can put my finger on it. So I'll put a little dot there, okay? Or you could just draw a line going all the way across. Then I'm going to look at my silt number, okay? My silt number is 20. So I'd come up on the silt side, which is over here. I find the number 20, and I'm going to go down. Now, why am I going down? Well, notice this arrow for silt is pointing this direction. Your arrow for clay was pointing this direction. So you're simply following the direction the arrow is going. And then the last one is sand. So it's number 20. So I'm going to come down here to sand, and I'm going to find 20, which is right here. And following this arrow pointing diagonally up, I'm just going to go up. Where all 3 intersect, that gives me my texture. And the texture under here says clay. So my soil texture type is clay. And all I would do is write that down. Now let's clear the screen and look at this one more time. For this one, we're going to look at our second sample, right down here. Now, to make things even more simple on you, what I usually do is I ignore the silt side altogether. Okay, so I'm just going to ignore this whole thing. Because if I can find 2 numbers that intersect, then that's going to be my third one. Now, if you want to match that third point up just to double check and make sure your answer is correct, you can do that. But just to make things a little bit easier, I'm just going to match up the 2 things. So the ones I like to match are clay and your sand. So again, clay's over here and sand is down at the bottom. So for clay, my number is 20. So I go down to 20 on the clay side and I draw a line that goes all the way across. Then I'm going to go down to my sand, which is 40, and I'm just going to go diagonally up till they meet. And where they meet is over the texture called loam. And if I clear the screen, you can see that right where they met is called loam. So then I would write down my answer, loam. Now let's do our last one. I'm going to change the color. Typically, when I'm doing these triangles, I don't actually write on the triangle because especially if you have a paper version, it's really annoying to keep having to draw and erase and draw, and it just gets so cluttered. So what I like to do is I put one finger on the clay number and I put one finger on my sand number, and then I go up and over and see where they intersect. So that's what I encourage you to do, especially since this is all virtual. So again, I'm only going to look to see where 2 of them intersect. So I'm going to ignore this 20. And I'm going to match up 10 for clay. So I have 10 here. And I'm going to put my finger on there. And then I have 70 for sand. And 70 for sand is over here. And for clay, you go straight across. And for sand, you go diagonally up. They intersect right here. It's in that same little shape where it says sandy loam. So sandy loam is your answer. Okay. So again, if you want to know where to go, you simply follow these arrows. But what I always do is I know if I'm only looking at clay and I'm only looking at sand, then I go straight across for my clay and I go diagonally up and to the right or left, for my sand. And if I can remember just to do my fingers in that motion, then I'm going to easily be able to do my soil triangle. Okay. If you have any questions on how to do this, then reach out to me. Let me know. We can set up a Zoom meeting. It's really not hard once you get the hang of it. Or if you want to pull up another YouTube video of someone showing you how to do the soil triangle, feel free to do that too. My feelings won't be hurt. But you can end this video and then go ahead and work on your soil triangle, which is on Canvas.